So last time we work on three other problems. This is the last problem that we're going to work on from chapter 4. And the signal is given like that. Then x of t equals to what? So we're going to look at the one period. It's going to be x of 0 when t equals to t over negative t over 2 to positive t over 2. And then t over 2, 0 t over 2 to t equals to big T. So in this case, because it's 0 for the second case, we just need to set up and find C of k for negative t over 2 to positive t over 2. So now we have C of k equals 1 over t naught integral. We're going to go from negative t over 2 to positive t over 2. And x of t, which is x of naught, and then e to the j omega naught t dt. Okay, so like last time, we're going to use omega naught equals to 2 pi over t naught. It's not like the first problem. First problem that we did in the chapter 4 is very similar to this, but that time we had the interval as a t naught. But for this time, we are not going to have the interval as a t naught. So very specifically, we said t over 2, t over 2. That's the only difference. And also in the previous one, we have a negative value for the second part of the signal. But for here, we don't as a 0. Let's do this. Then this equals 1 over t naught, 1 over t naught x naught times 1 over negative j k. Omega naught is 2 pi over t naught times e to the negative j k. Omega naught is 2 pi over t naught times t from negative t over 2 to positive t over 2. Okay, we can cancel t naught and t naught, x naught as a numerator over negative j 2 pi k, and then we have e to the negative jk 2 pi over t naught times t over 2 minus e to the negative jk 2 pi over t naught times negative t over 2. Then 2 and 2 can cancel. And at this point, I see as a negative in between the exponential function. That means it's a sine, not cosine. And for the sine, we have to have a denominator as a j2. We have it here. So what I'm going to do, I'm going to multiply -1 for here, and then bring j2 at the denominator. Then we have x naught over pi k, and then we have j2, this guy first, e to the jk t over t naught pi minus e to the negative jk t over t naught pi. Then this is sine. We have x naught over pi k, and we have a sine. Other than j, we have k t over t naught pi. When you have a sine with the pi, we have sinc function. For the sinc function, the pi is inside of that. So we need to have a numerator and denominator with the pi x, and the sine. Then we can change that to sinc. So we have a pi, and inside we have a k t over t naught. So what we can do, we're gonna put denominator as k t over t naught, and then we need to multiply exact same thing for the numerator. Then the coefficient, this whole thing, this thing is gonna be sinc function, and the outside, we just need to cancel k and k. That equals x naught t over t naught times sinc k t over t naught. So our final answer gonna be sigma k goes from negative infinity to positive infinity. We have x naught t over t naught sinc k t over t naught times e to the jk omega naught t